Hello students, welcome to Sourabh Sir classes. Today in this video we will discuss and solve some of the new problems on this CSIR UGC NET JRF exam. These type of problems used to come in this exam, and we will discuss on this type of numeric problems, both conceptual and also memory based. Now our first problem is number 1. According to crystal field theory, Ni2 plus have two unpaired electrons in a octahedral geometry only, B square planar geometry only. Number C, tetrahedral geometry only. And C and D, both octahedral and tetrahedral geometry. Now if we see now, if we once again I am repeating the problem that this, according to the crystal field theory, Ni2 plus have two unpaired electrons in octahedral geometry only, square planar geometry only, tetrahedral geometry only, and both octahedral and tetrahedral geometry. Now in case of Ni2 plus, the electronic configuration is 3d8 4s0, and before it there is argon core 3d8 4s0. And now if we see the geometry, hybridization, possible hybridization and number of lone pair, we will find that or number of unpaired electron, better to say number of unpaired electron here we see for octahedral geometry the possible hybridization is sp3d2 and number of unpaired electron is 2. While for square planar the possible hybridization is dsp2 and number of unpaired electron is 0. And for tetrahedral geometry where hybridization is sp3 and number of unpaired electron is 2. So these three types of hybridization and three types of geometry is observed for 3D84S0 Ni2 plus structure. So Ni2 plus can give us these three type of complex, structural complex. One is octahedral, another is square planar, and another is tetrahedral. For octahedral, the geometry is sp3d2. For square planar, it is dsp2, and for tetrahedral, it is sp3. So what we see is that so these three types of hybridization is observed. In case of octahedral and tetrahedral, we see that there are two unpaired electrons. So in octahedral and tetrahedral, there are two unpaired electrons. So we can see the correct option is D. So D is the correct option. Our next problem is NiCN4 and two minus and NiCl4 2 minus are 2 minus complexes are both diamagnetic B both paramagnetic C diamagnetic and paramagnetic. Diamagnetic and paramagnetic respectively. And D anti-ferromagnetic and antiferromagnetic and diamagnetic respectively. Now I am once more repeating the question. NiCN4 2 minus and NiCl4 2 minus complexes are both diamagnetic, both paramagnetic, or diamagnetic and paramagnetic respectively, antiferromagnetic and diamagnetic respectively. Now to solve the problem, we see that if we make a table like this, compound, hybridization, and number of unpaired electrons. We will find here in NiCN4 2 minus, it is here the hybridization will be DsP2 and number of unpaired electron will be 0. Here this cyanide is a strong field ligand, so it will pair up the unpaired electron and so it will form a square planar complex with DsP2 hybridization. On the other hand, NiCl4 2 minus, this will form sp3 hybridization and it will have number of unpaired electron is 2 and this will be paramagnetic. So what we see is that diamagnetic, this one is diamagnetic and this one is paramagnetic. So C is the correct option. So this is diamagnetic. So NiCN4, this is diamagnetic having no unpaired electron, while NiCl4 2 minus, it is paramagnetic having 2 unpaired electron. So option C is the correct one. So correct option is equal to C. So C is the correct option. Hello students, welcome to Saurabh classes. Today we have just started solving the questions on CSR UGC NET GRF exam, the questions suitable for this exam, and we have already discussed in our previous video few examples. Now in this video we are starting with some other examples, like number 1, which of the following spectroscopic technique will be useful to distinguish between MS double bond M MS S double bond C double bond M and M N triple bond C double bond S MS C triple bond N. These two molecules MS C triple bond N and N C double bond S binding modes. A NMR, B IR, C EPR and D mass. Now, I am once again repeating the question. Which of the following spectroscopic technique will be useful to distinguish between MSCN and MNCS binding bonds? Now, in case of two species, for MS C triple bond N. Here we have this triple bond is stretching in higher frequency or wave number and in case of M N double bond C double bond S, here this double bond here is double bond or is stretching in lower frequency or wave number. So from this stretching frequency, so we can distinguish these two molecules by using the IR spectroscopy. Since these molecules are differing in stretching frequency, so they can be identified by IR spectroscopy. So the correct option is B. So correct option is equal to B. Our next problem is which of the following compound show a charge transfer band. A lanthanum nitrate, B ceric ammonium nitrate, C manganese manganese 2 acetate, and D copper 2 sulfate, pentahydrate. Now Uh, Now I am repeating the question. Which of the following compounds show a charge transfer band? Lanthanum nitrate, ceric ammonium nitrate, manganese acetate, and copper sulfate. Now among these four, now first of all we see that this charge transfer complex is formed when this metal is in higher oxidation state, and number two, that ligand have reducing property. In this case, among these four complexes, this ceric ammonium nitrate, here ceric is in +4 oxidation state, and this ceric ammonium nitrate, this is NH4 whole 2 CeNO3 whole 6. Here this Ce is in +4 oxidation state, and which is in higher oxidation state, and these can form a charge transfer complex. And this is for this charge transfer complex is formed between this ceric and nitrate NO3 minus. This is a bidentate ligand, and it has coordination number of 12. So Ce has coordination number of, this has coordination number of 12. So we get the charge transfer complex here, ceric ammonium nitrate, and the correct option is B. So B is the correct option here.